command lines, command line interface, and go from the different modes. Go over some of the basic commands, how to get into different modes, how to get out of different modes, how to save your configuration, how to show your configuration. And then I'm going to go over how to address interfaces. We're going to set up a very basic network with OSPF. And then we're going to jump back into access control lists and start playing around with how ACLs work. Okay? So, before I do that, one of the things that I absolutely do not like about GNS3, and this is personal preference, I'm not saying you have to do it, is I don't like using PuTTY. I really don't. You know, call me a PuTTY snob or whatever. I don't know. I don't like it. I use a terminal emulator called TerraTerm, and what they did here in one of the latest revisions of GNS3 is you can actually change the command interpreter that you use. How you do that is, well, actually, PuTTY comes with GNS3. If you click on the console to devices, it'll just pop up, right? And you can get into the router and do whatever you need to do, okay? Or close it out, whatever. If you want to change it to a different terminal emulator, you can go to Edit and Preferences, and then Terminal Settings, and right here, I have one for TerraTerm. Alright, I run TerraTerm on my computer. I use it for IRC and remote 3270 access to minis and mainframes and everything else. So now if I were to console, it's going to bring up TerraTerm instead of PuTTY. Okay, so R1 and R2. Okay. Now when you go into a router, it might be a little bit hard to see, but you get the prompt, all right? You see this prompt here, it's R2 greater than, okay? This is your basic prompt, your standard user prompt, okay? If you want to see what commands you can run, the help file is the question mark. You just do question mark and run through the commands of the help file. So I have, I can disconnect, disable, I can work with connecting to different things, I can use ping command, alright, I can try to terminal to another system, right, a lot of things I can do. 2 pages worth of commands. Well, that's great. I can do a lot of things, I can show a lot of things, I can kind of play around with stuff. I cannot do one single command to configure this system. I have to be in what is known as privileged exec mode. And also need to be in that mode if I want to get any detailed information from protocols, interfaces, etc. So how I do that is I type in enable at that prompt. My cursor changed to a pound sign. Greater than, standard mode, pound sign, privileged executive mode, or privileged exec mode. Alright? If I want to do any type of command, now if I do the question mark, you can see that I'm going to roll through about, instead of 2 pages, about 4 pages, 3 or 4 pages. Alright? A lot of the commands are still the same. I do them in either mode. I have more commands to do in privileged exec mode. Alright? If I want to do a specific command, say I want to look at the startup config or the running config. Alright? If I didn't know what to put after show, I can put show question mark, and these are all the subcommands under the show command. So the question mark is a really good command to know that you can put after any command and understand what it can do. Now, here's the next thing I'm going to do. I'm going to erase both of these. Hope I didn't screw up GNS3. This works in a real router. Maybe virtual routers don't like that. Hard reset. There we go. While they're booting up, let's kind of go over the topology here. We're going to set up these two routers. We have a serial link, two Ethernet links, two switches. We're going to IP the fast Ethernet ports, serial ports, all right, on each of these networks. We're going to put in a routing protocol called OSPF, so we can get routing between the two LANs. Because when you set up routing, all right, when you set up the two routers and you connect them, well, they'll see each other on this interface. But unless you put in a routing protocol or static routes or give the router some information, they will not be able to see each other's local area networks. Good, so it's been completely erased now. Alright, so if I want to get into enable mode and actually be able to configure anything like an IP address on an interface, a routing protocol, an access list, which is what we're going to talk about here next, alright, I need to be able to go into privileged exec mode and then go into some sort of configuration mode. All right, I'm going to configure the system from terminal. All right, which is going to change my prompt, and then I can go into interfaces, routing protocols, line protocols, all kinds of other good stuff. All right, a couple of things. Once I go into enable mode, I can do tab completes. So as you saw there, I started type in a command, I just hit tab. Once I get to a certain area that it is unique, I can hit tab and it'll complete the command. It works just like Linux. Alright? So I can do that. It will also recognize the command in shortened form. So, all I have to do is type in CONF space T, for example, and I can get away with just typing in a shortened command. I don't have to type the command all the way out, because after all, network engineers are inherently lazy. We don't like typing a lot. If we wanted to type, we'd be programmers. So, anyway, from global configuration mode, which is where we are now, I can go into routing protocols, interfaces, individual lines, the console line, the auxiliary port line, the virtual terminal lines, or do what they call global commands as well. So in this case, for R1, I need to configure this fast Ethernet port and this serial port. So to get to the interface of a port, I type in interface and then the port number. So as you can see here, F00 is that port. It's short for fast Ethernet 0/0. I don't have to type out fast Ethernet 0/0. I can just type in F0/0 for short. And my prompt changes again, this time to config-if. Okay. From here, I can give the interface an IP address. One quick step. If I ever want to look at the configuration, or if I want to look at the global config, typically what I would have to do is exit all the way back out to privileged exec mode and run the command. Well, somewhere along the lines of iOS 12.3, they put in an interpreter in the command structure that will allow me to run any command from any sub-command area. That interpreter is do, D-O. So if I want to look at the running configuration, or the start configuration, for example, if I were to type in show run for running config, it's going to tell me invalid input. But if I put the interpreter do in there, and it's in to preempt it, it's going to go through all of the different command sections until it finds show run, and it's going to execute that command. That. As you can see, fast Ethernet 00 is currently shut down. It has no IP address whatsoever. Okay, so I'm still in that interface. I'm going to give it an IP address of 10.0.0.1. I also have to give it a subnet mask. If I did a question mark, it would say, what's your IP subnet mask? Well, it's a 24-bit subnet mask, which is 255.255.255.0. If I keep doing a question mark, once I see a CR, carriage return, that means I can hit enter and take that command. Okay? The interface, I don't know if you noticed it or not, was also shut down, meaning it's off. So even though I put the command in there and gave it an IP address, the interface is logically shut off. I'm not going to be able to do anything. So, to take a command out of the configuration, you have to preempt that command with no. So, since in the command configuration, as we see here by the show run command on Ethernet 00, there's my IP address. It's in shutdown mode, or it's shut down. So to take that out, I would put in no space shutdown, or simply no shut for short.
We only do that in the config if mode.
I am in config if and config interface mode.
So you can
I'm actually in the interface. I have to be in the interface.
okay. So have to be in the interface. C
Yes.
no shut. Okay.
That is correct. Because if I did no shut in global configuration mode, it's not going to turn on anything. It doesn't know what to turn on. Okay? And as you can see here, the line protocol came up and the interface came up. Okay? Now let's do the same thing for serial 10. We have to do one added step for serial 10. Since it's a serial interface, it's not Ethernet, we have many choices for encapsulation types. Encapsulation types are the layer 2 protocol in which is going to be used to bring up signaling between the two devices. Alright, just like Ethernet is a signaling protocol, here on a serial it's going to default to HDLC, alright, high density link control protocol, or we can change it. We can change to X.25, we can change to PPP, we can change to a lot of different things. So if I exit out of there and I go into interface S1/0, right? And I choose an encapsulation, space, question mark, I can run HDLC, frame relay, LAPV, which is an X.25 derivative, PPP, SMDS, or X.25 raw. Okay? You're going to run 1 of 2, actually 1 of 3, probably in your lifetime. Frame relay, maybe, although frame relay is dying out. Okay, HDLC, which is what it defaults to. But for best performance, you want to use point-to-point protocol, PPP. PPP is structured in a fashion that is A, more secure, B, it is faster, and C, it is more secure. Yes, I said more secure twice. This is after all the security class. So I'm going to put in encapsulation PPP. From here, I'm going to put in the IP address. So it's IP add. In this case, it is 2.2.2.1. It's a 30-bit subnet mask. A 30-bit subnet mask is 255.255.255.252. I also have to turn this interface on. How do I do that? No shut. You guys are paying attention. Good job. Okay? Now, if you remember before, I got a link up, and I got a line protocol up. Well, I didn't get a line protocol up this time. Why do you think that is? Because R2 is not configured yet. Before we go to R2, if I do a show run, I can see that, hey, there's my interfaces, they're configured. Great. Not a problem. But I have 2 configuration files in my router at all times. I have the running configuration, which is actually what it's executing. And I have a startup configuration, which is where it boots from. Now, if they don't match, that's a problem. Because right now, if this router were to reboot or lose power and come back up, all the changes I just made would be lost. So I have to write those changes to memory. Okay, or save the configuration. How I do that is, if I exit all the way out, I can write to memory, or WR memory, or WR space mem, or, remember, network engineers are inherently lazy, WR works just fine.
So when you do write the WR, that saves it?
That writes the running config to the startup config.
You have to exit all the way out, or can you use the do
You can do, yeah, absolutely, you can do WR. Absolutely. Good question. So, Oh, I have one more thing to do. Well, actually, I'll come back to R1. Over here on R2, go into enable mode, config terminal mode, interface, fast Ethernet 00. Fast Ethernet 00 is 192.168.0.1. IP add 192.168.0.1, 24-bit subnet mask, and we got to turn it on, no shut. Then on its interface 10, hey, you see everything came up, right? That's good. Interface S1/0, IP add 2.2.2.2, 30-bit subnet mask, 255.255.255.252. Oh, I forgot something. What did I forget?
Encapsulation.
Encapsulation type. Encapsulation, or I can just type in encap for short. PPP. Now I have to turn it on. How do I turn an interface on? No shut. Now, you get both the interface to come up and the line protocol to come up. Okay? Line protocol in this case, PPP. To get all the way out of configuration mode back to privileged exec mode, I can type exit until I get all the way back, or I can use a hotkey. Hotkey is Control plus the Z key. So if I hold down Control and then hit Z, you see that I go all the way back out. If I do a show run here on R2, see everything that I've done, but if I do a show start, no startup config is present. What do I need to do? Write mem. Don't forget to write to memory. If you forget to write to memory, you can get through 2, 3, 4, 6 hours worth of programming. Go to save your file. Whoops. I didn't write to memory. You go into the GNS3 folder, your project folder, and your config is blank. I will not have any pity on you.
Wait, so if you do write memory, it shows up in the
You see right here, C:\temp acl-lab topology.net. That's a project I started. So if I go there, C temp ACL lab configs. Uh-oh.
That's what I was calling around.
Here's how you overcome that. File, save. See here? Bam, bam. Now if I go back, F5 that, there's my configs.
Oh.
Okay?
Last quarter we had trouble with we would start over every time. We didn't know how to save it.
Well, now you know. And they're right there. See the IP addresses. Copy and paste back in if you have to. Okay?
How do you copy and paste it back in?
Well, with PuTTY, it's kind of hard. This is where I went to TerraTerm. All right? So, let's do this. Go back to post R1. Right. So, now, what was the question again? I'm sorry, I got sidetracked there.
How do you copy and paste it from that config file that we saved into?
So, I would do that. So I'm in R1, right? I come up here and just select everything. Right clicked, copied. Go into configuration mode, right? And then from here, with TerraTerm, I can just paste. It's going to tell me, do you want to copy all of this to your router? Yes, I do. You can do the same thing in PuTTY. There's just no commands. There's no ribbon right here. So you just have to right click. Okay? One of the reasons I like using TerraTerm, a little bit easier to use. Okay, so next, I'm in R1. So now I can ping 2.2.2.2. 5 bangs, that's good. That means it hit. I sent 5 ICMP echo packets to 2.2.2.2. They were successful. I had a round trip of 20 fastest, 28 normal, and 40 longest microsecond. Now from our 1, I want to try to ping 192.168.0.1. That's the LAN over there, right? That's a problem. Why can't I ping the LAN? Anybody have an idea? Why can't I reach that 192 network?
They're different.
What's different?
The fast internet and the slow, whatever that stands for.
No, that's just physical connection in layer 2. I have no route. R1 has no clue at all where the 192.168 network is. Okay? Here's how I know that. If I look at the routing table, and the way I look at the routing table, I erased it. The way I look at the routing table is with the command show IP route. So if I show IP route, I can see that I see the 2 network. I see the 10 network. Well, there's no 192.168 network there. I have no clue where it is. Well, I have to do one of 2 things. I either have to tell it how to get to the 192 network via a static IP route, or my network, I can configure a dynamic routing protocol. What I'm going to do is I'm going to configure open shortest path first, which is a link state dynamic routing protocol. Hopefully you learned that from 347. I'm going to set up R1's serial interface and R2 serial interface in area 0. R1's fast Ethernet in area 10, and R2's fast Ethernet in area 192. The big thing you need to know about this is, with OSPF, all of your areas must be adjacent to area 0. On your tests, on your labs, if you have them with OSPF as your routing protocol, I promise you I will not make you do a virtual link. That's a little bit beyond the scope of this class. Right? We're not going to, everything is going to home to area 0 if you have OSPF. Alright? So, how I set up OSPF as a routing protocol is I have to go into router configuration mode. So, how I do that is go back to config T, and to go to router configuration mode, I have to type router. And then the protocol that I'm going to use, in this case it's OSPF. And then the process ID. You see it's up there, the process ID is process ID 1. So OSPF, router OSPF 1. then to do a very simple configuration of OSPF, I just have to tell it what networks it can advertise. What networks it can advertise. So I type in network. For R1, it's going to be 10.0.0.0. Then I have to do a wildcard mask, or wildcard bits. All a wildcard mask is a subnet mask inverted. So if a 24-bit subnet mask is 255.255.255.0, an inverted subnet mask would be what? 0.0.0.255. And last but not least, I have to tell it what area that network is in. So what area is the 10 network in? Area 10. Enter. I have one more network up here, which is the 2 network. So net 2.2.2.0. And its inverted mask, now it's got a 30-bit mask, which is 255.255.255.252. What would the inverted mask be for it? Dot 3. 0.0.0.3. Good job. And it's in area 0. Yep. I didn't do enough. There. Now, just kind of watch R1 there. Let's go back to R2. And let's configure the routing protocol here. Router OSPF 1. Its network, now it has the 192 network, 192.168.0.0. 24-bit wildcard mask, 0.0.0.255. And it's in what area? 192. It also is in the 2 network, right? It's participating in the 2 network. Now you'll see when I bring it up in the 2 network, OSPF is going to bark out a neighbor advertisement. And what OSPF does is, when it barks out a neighbor advertisement, if a corresponding OSPF router is on the same network and hears it, it's going to respond. It has to be in the same area. If it's in the same area and participating in the same network, they're going to form what we call an adjacency. Okay? Once that adjacency is formed, they are going to trade routing tables. And when they trade routing tables, R1 in this case is going to learn about the 192 network, and R2 in this case is going to learn about the 10 network. Okay? Case in point. If I do a do show IP route on R2, I don't see the 10 network. Everybody get that? Cool. Still in router configuration mode. I do net 2.2.2.0, 0.0.0.3, area 0. Watch what happens when I hit enter. See it on both of these. They form that adjacency. Now, if I do that show IP route on R2, I now see the 10 network. Yeah.
Sorry, it was
It's
probably
okay.
pretty obvious. I'm pretty sure it's obvious, but for the areas,
Mm-hmm.
I know they're given to us here, but when we're trying to figure it out, is it just the first offset of the?
No. That's arbitrary. Okay. Now, in the labs and in the exam, I will give that to you.
Okay.
If you're out in the wild, so to speak, hopefully somebody has it documented somewhere. If you're building what we call a greenfield environment, pick something out of the sky.
Okay.
Okay?
So they're given to us, so we usually make it up.
Yes.
on the field.
I will give it to you, or if I don't give it to you, pull it out of the sky. Good question.
Yeah, I was just wondering.
No, it's a good question.
Because I got area 10, 192, but
Sure.
area 0 was like,
That's
where'd
fine.
you get that?
I just did that for simplicity's sake to not mess anybody up. Okay. All right. Moving on. Now that I have full internet connectivity, go back to the lecture here. We're gonna go back to talking about ACLs. Now, for your labs, when you get into lab 2 and 3 and test number 1 and 2, that right there are a derivative of it, whether it is setting up EIGRP or RIP or static routes. Okay, IP addressing everything, getting that internet connectivity, internetwork connectivity. That is going to separate you, okay, the A students from the B students, the B students from the C students, the C students from the D students, and so forth. Because that is question number 1. If you don't get that, you lose automatically lose the letter grade. Period. You have to have full connectivity so that you can make everything work. Hence why I said it was important to take 347 before you take this class. Right? Now, nothing that you can't overcome working with maybe a study group or your partners or doing a little bit of research out of class or recording. Right? Alright, or taking good copious notes. What are you up to, page 3 now?
Yes.
Awesome. God, I need a transcript. You know, I woe the day that I have step back here real quick. I went to my last PhD residency at Arizona State last month, and one of my fellow students that was in there, he is completely 100% deaf. And as part of what the university did is they had a court transcriber, on what they call a court stenographer or whatever they're called, sitting there typing as the different presenters and lecturers and PhDs were coming up and giving us information on our comprehensive exams and our dissertation and everything else. And he was getting everything on a screen. He was watching everything on a screen. So, like, shorthand from hell, man. That's awesome.
Thank you.
Okay, access list. All right, when do we use an access list? Well, it's called for when we have to lock down applications or use advanced features or control resources of applications in depth. There are 2 types of access lists that we're going to use in this class. A standard access list and an extended access list. Okay? And a standard access list, they're numbered, basically. Or they can be named. Use them as a named access list. Alright? I messed this up last time. Okay? A standard access list is going to be numbered 1 through 99. An extended access list is going to be numbered 100 through 199. Now, a standard access list is written access list, number, permitter to 9, network number, wildcard mask, where the network number equals the source IP, and the source IP only. Standard access list only filter on source IP number. A little limiting, right? A little limiting. Okay? So if I were writing a standard access list, I could only inspect based on the source IP address. Okay? So I can either permit or deny where traffic is coming from, not where it's going to. An extended access list, alright, will allow me to permit or deny based not just on IP, that IP source, but on layer 3 or layer 4 protocol. It'll allow me to permit or deny based on a specific IP, a specific host, or like standard access list, a network and wildcard mask. But it will not only allow me to do source, it will also allow me to do destination and by destination port number or source port number. I can also do it by source port number, although that's you don't want to get into that. Okay, it's not really necessary. But it'll do it by destination port. Yes?
What were you saying about the numbers? We have 8.
When I get into it, it'll explain itself.
Okay.
Okay. All right. It's just a piece of the code command. All right. So what I'm going to do now, covered. All of this is done via IPv4. So we're going to concentrate on. We're not doing this. You can do this with IPv6, but we need to crawl before we run. So we're going to concentrate on IPv4. All right. In this class, we're going to use RFC 1918. All right. RFC 1918 is what? May explain that to me. Private IP addressing. Where would you never find these addresses? Never, ever find those addresses on the internet. They're for private use only. They are not publicly routable. Okay? Now that's important because you're going to get questions in your labs and in your tests where you have to filter that using a standard access list. Using a standard access list. So you'll build an egress filter stating that if any packet is destined to the internet with that source address, it gets dropped. That is best practice for any edge router that's on the internet. Any edge router on the internet. Now your ISP is going to filter it anyway inbound, but it's just best practice to do that. Next. I hope I don't need to cover subnetting, inverse subnetting, or wildcard masking, private IP ranges, and IP registration. You guys should have that. If you don't, do a couple Google or Wiki searches on it. You should have that down by now. You should have that down by now. Okay? So, ACL configuration. There's a couple steps you need to know. You create the ACL, and then you apply the ACL to an interface. Alright? Creating the ACL, if you look at table 2.5 and 2.6 in your book, kind of explains it. You also, it gives a map of the traffic diagram. Alright? Example of this map diagram is when traffic goes into an interface. Alright, and an access list is there to be used. Or in this case, 2 access lists. It follows a certain flow. So when packets come into an interface, they enter the receive buffer. If there's an access control group on that interface, that acts as a pointer. You all remember what a pointer is from programming class? You all remember what a pointer is from programming? Good. Points to an ACL. That ACL is then a list of code that is basically an inspection standard, and it goes to the parameters of that inspection. Okay, line by line. Beginning to end. Forward to back. Front to back. Right? And then after it goes through that inspection process, that packet is either allowed or denied. Now, as it goes through that access list line by line, once it hits an entry where it's permitted, it stops. Stops that process. It stops going through that access list. And it gets put to a route table check. So once it's past that access list, is that destination address in my route table? If it is, great. It gets processed to the transmit buffer of the exit interface. If it's not in the route table, the packet gets dropped. Okay? Once it goes to the transmit interface, it goes to and sees if it has a exit access control group, which acts as a pointer to another access list, if that access list exists. Okay? If this access list doesn't exist and this access list doesn't exist, these steps are just skipped. Okay, but if one exists, it then looks up that exit, that egress access list, and it goes through the same process until it's matched. If it's matched, great. It gets put to the transmit buffer and gets shipped out that interface. If it doesn't get matched, it gets dropped. If it goes through all the way through the access list in either step, there's an implicit deny at the end of an access list. Meaning, if you didn't match anything in my access list, you are automatically dropped. Okay? So that's that entire process of how an access list operates. Okay? And how a packet traverses a router. So you have to understand the direction the ACL will be traveling and whether it's going to be inspected inbound or outbound. That's very important when we get to configuring the access group command on the interface. So remember this, because this is a very, very, very rookie mistake, and you'll lose 5 points for every access list that you have to configure. You could do a beautiful access list. You could get everything right. Your permit statements, your deny statements, your source and destination, your ports, everything else, right? And you're set up to get 10 points on that question. You don't apply it to the correct interface, okay, at all, you'll lose 5 points. You apply it to the interface, but you put it in the wrong direction. You apply it inbound when you should have applied it outbound or vice versa, you'll lose 3 points. Okay, so pay attention to this when I go through applying the access list with the access group command, the IP access group command. Okay, and pay attention whether I apply it inbound or outbound. And that's based on where the access list is going to reside. Okay, we went over the processing piece. And went over the processing piece. So now we're going to implement a couple of ACLs. First thing we're going to do is we're going to implement a basic plain Jane inbound standard ACL on R2's S10 interface. Okay? And we're going to deny IP. We're going to break this network. We're going to break the network. We're going to break OSPF. Okay? So, here's how we do that. On R2, I'm going to go ahead and write a standard access list. The command is access list, a number between 1 and 99. I'm just going to pick 10. It's arbitrary. I then have to say permit or deny. In this case, I'm going to deny the address from which I'm coming from. So I'm going to deny the 10.0.0.0 network. It asks for a wildcard mask, 0.0.0.255. Enter. Now I need to permit everything else. So I'm just going to put a access list 10 permit IP any. Oops. Standard act permit any. There. If I do a show running configuration, there's my access list. So, alright, it'll permit anything from the 10 network, it'll deny anything from the 10 network, it'll permit anything otherwise. I need to apply that to the S10 network. So if I go into the interface serial 10, I use the IP access group, the number which corresponds to the access list, which is 10, and then is it inbound or is it outbound? In this case, it's going to be traffic coming into the interface. All right, it's now applied. Actually, I was joking about breaking OSBF. I don't want to do that. That would be bad. Okay, so you see here on serial 10, there's my access group command. All right. Now, if I go back to R1, and I ping 2.2.2.2, hey, it works. All right. My source address when I do a ping, okay, from a router is the IP address of the interface that those packets are exiting. That's the source address. Now, I can manipulate that with the ping command. I can do what we call an extended ping. So I can tell it, you know what, I want you to form the packet so that the source address is this IP instead of this IP. This is how you do that. You type in ping and you hit enter instead of putting an address afterwards. It's going to ask you, well, what protocol do you want to use? Well, I'm going to use IP. What's the target address? Well, the target address is going to be 192. Actually, we did 2.2.2.2. Okay. How many times do you want to ping it? 5. What's this datagram size? Make it 100 bytes. Timeout between each packet if failure, 2. Do you want to use extended commands? Yes, I do. What's the source address? So this time I'm going to make it the IP address of the fast Ethernet port, which is 10.0.0.1. Everybody remember that? Right here. 10.0.0.1. Okay. Service is 0. Everything else is default. Just kind of hit enter all the way through. U stands for unreachable. That access list blocked it. That access list blocked it. Okay? Now, I go to R2. And I simply remove it, no IP access group 10 in. Go back and do the same thing. It works. Okay? So that's how a standard access list is written and applied to an interface. All right? Now, let's take this one step further. This is very important for Lab 1. This is how you can control access, like telnet access to a router. So first off, I need to set up a user and set up telnet access to R2. How I do that is, if I can create a user, let's just say I'm going to create a user B Brown with password Cisco. Okay. I'm going to set an enable password of Cisco as well. Access is controlled by some sort of port, either a physical port or a logical port. If you had a physical router, it would have 2 ports on it. Have its auxiliary port and its console port. And you can cable up to the console port, use a program like TerraTerm or PuTTY, and physically connect to it. All right? But I'm simulating a network, so I'm simulating that I'm getting these routers via some other protocol. So if I were to be on R1, say I'm where R1 is located, and just for argument's sake, let's say R1 is Los Angeles and R2 is New York. I couldn't physically walk over to R2 and connect to it and configure it, right? I'd have to actually use some other means. All right? Typically what's done is maybe Telnet or SSH. So in this case, I'm just going to use Telnet as an example. So I need to go into my virtual terminal lines. So just like going into an interface mode or router configuration mode, you also have a line configuration mode. Okay? Your line can be your console, can be your aux port, or it can be your virtual terminal lines. All right? if I do a show run and look at the configuration, those configurations are at the very end of the config file. Line con, line aux, line bty. As you can see, I have login here already. I need to change that on the bty line. So I'm going to go into line configuration mode, line bty 04, just like it's in the config. Change that to login local. Write that to memory real quick. Now if I go to R1 and I type in telnet and tell it to go to 192.168.0.1, I'm prompted for a username. Give it B Brown. It's asking for my password. I give it my password, which you can't see. Hey, I got into R2. If I type in enable, I put in an enable password. Again, that's not going to be shown when I type it. Now I'm in R2. Pretty cool, huh? Now let's develop an extended access list that will block that, but permit all other traffic to go through. Here's how we do that. Let me get out of R2 first real quick. So let me just do a little bit of cleanup here real fast. I'm going to remove access list 10. How I remove a command is I preempt it with no. Check my work. And I can see access list 10 is gone. Completely. Now I'm going to write an access list. 100, 101. Okay. Permit. Actually, excuse me, deny. So I want to deny the traffic. Alright. Now, typically, I could put in a specific IP address, specific IP network, but let's just say that I want to deny telnet traffic wholesale from anybody. There's a keyword that I can use here, okay, after I tell it what protocol, which would be any, okay? Now remember, an extended access list works on source and destination. So, telnet uses what protocol for transport? You may know. TCP, good job. TCP. Alright. Any source, any destination with port number. What's telnet's port number? EQ stands for equals. What's telnet's port number? 23. Okay. A little bit of help. This website, you just do a iana.org, or excuse me, a Google search for TCP port numbers. This is the first link that pops up. This is older than dirt. This has been on the internet since, geez, I was like a teenager. It tells you every port number and what it is. So if we go to port 23, that's telnet. Tells you who developed it, or who, excuse me, not developed it, but who registered it. And it will tell you the RFC that it works under. Okay? So when you see items in your labs, in your test of allow traffic for this protocol, deny traffic for that protocol, and you're unsure of the number, the access list, you can go to this website and figure it out. You can also, because Cisco got smart and they wanted to help you, why I don't know, but they did. You can also do the EQ space question mark, and it will give you the most common protocols and port numbers. As you can see, Telnet's there. So I can just type in Telnet or just give it port 23. Now, since I denied Telnet, what do I have at the end of any access list? No, not that's access group, not access list. An implicit deny. So if I don't put a permit here, I'm not only going to block Telnet, I'm going to block everything else. Very common rookie mistake. Okay, hey, I wrote my access list, I'm good to go, and it was a deny. Right? And you didn't permit stuff going back through. You denied everything. Yeah, worked really well, a little too well. So we need to put a permit in here. Okay? So I'm explicitly wanting to deny one certain protocol in this case. And I have to let everything else through. Okay? Not really a good practice. I'm using this more for an example than anything else. You should never have this in any access list whatsoever. Okay, so I just want to make that caveat there before I move forward. Now, if I find permit IP any in any of your access lists, that's a bad thing. You're going to definitely lose points. Okay? So all of you guys who are recording this, make sure you pick that point up. So now if I go back to R1, and I try to telnet to 2.2.2.2. Oh, wait, what did I forget to do?
Right memory.
No.
Huh?
What did I forget to do? What did I not apply? What? The access group. So, int s1/0 IP access group 101 inbound. There. Try this again. I got a destination unreachable, gateway or host down. That access list is seeing, okay, forget this, you're done. Rocking packets. Now, another thing you can do is you can set up logging. Okay. Now if I go back through here, look at my show run. Copy my access list. This is how you write scripts. Put in a WordPad. Alright, and do no access list on okay, and then paste that in. What the log does is it will log any hits on that access list. So, if I do this again a few times, you can see that I get log entries on access list 101 that it's denying from that source address. Very, very, very key, especially if you want to watch your traffic. If I come back here and I do show access list, do show IP, respond. Show access lists. Access list 101, deny telnet, 3 matches. Permit IP any 8 matches. Why am I getting matches on my permit? I didn't do anything. I didn't ping anything since I started logging. Anybody know? Any idea? Let's find out. Okay. Let's go back here and change that permit IP any and put log on it. So it's in there, right? Let's just look real quick, okay? So, got 2 matches there, no matches there. If I try this again, see I get hits on the deny. We want to look for hits on the permit. Right? Got 5 matches and 5 matches. I should have some sort of logging here shortly as to why something is getting permitted. Here's why. See this here? It's going to show it once. Permitted OSPF 2.2.2.1 to 2.2.2.2. So it's allowing OSPF communication between the 2 routers. Okay? Fun times. To look at the logging history, if you do a show log hist, okay, it'll give you a little bit of information on messages ignored, dropped, etc. Okay. Moving on. So, do I have anything else to cover tonight? You guys are a quieter group than the first group.
Later at night.
Must be. I went through that way faster than I did at 6 o'clock. I had a lot more questions, I think. A lot more people. I also had to write everything up on the board. So, you get the benefit of, I'll let you guys ask. Do you have any questions at all? Ask them now.
So on the test, do we have to do like what you're doing? And we,
Yep. That's why it's going to be real important to do your labs. You do your first 2 labs before you do your first test. And your first test is darn near identical to your second lab. I mean, I think I changed IP addresses.
so basically, you do your labs.
If you do your labs, you do well in your labs. You look at my feedback from your labs, you'll do fine.
Is that same for the license test?
Yeah.
I got a question regarding the 2 router connect to each other through the serial cable.
Yes.
In the
How did that get set up?
yeah, what does that look like? I never see that before.
I think I may have missed that in this class, since I did this in the first class. My fault. So if you highlight the 2 routers and you right click and you go to configure and you select the router here, you get this slots tab. If you go to the slots tab, what I did is this was blank. I selected this NM4T. Okay. Clicked OK. I went to the link, add a link, and all I did is I went to manual, selected a router, I selected S10, or actually I'll select S11. Get that, I come over here and I selected S10 over here. That's how I made that connection. Okay?
No, my question is the connection. We know that, but what does it look like the serial, the cable things by connecting the physical? Yeah, is that just? I don't see.
It depends on the interface, honestly. It depends on the interface.
I see.
In this case, it may be a 25-pin blue serial cable that goes in the back of a router. That's really, really, really old school. You won't find that anymore.
Yeah.
High-speed serial interfaces, a little more recent, so you don't find those too much anymore. Honestly,
because the one.
Honestly, what you'll find a serial interface now is when you connect an OC carrier, an OC circuit into a router of some sort or a switch of some sort, it will come up as a serial interface.
Okay.
All right, as a serial interface. It may come up as a gigabit interface these days. Cisco has changed a lot of their the way they represent interfaces.
Okay.
Good question. Any other questions? Yes.